Hi guys, welcome back to our channel. Today's class I am going to teach about non-bistable in VLSI design. So previous video we discussed stable in VLSI design. If you need it, kindly refer the video. So in this session I am focus these four things. First one is symmetrical, CMOS implementation, monostable and astable. We will discuss one by one. So first one, symmetrical. So what is symmetrical? So symmetrical in the sense it change the sine waveform into square waveform. So it's called as a symmetrical. So symmetrical is a device. This device operating in two important property. So two important property. So first property is the input value. So the input is slowly increase. The input is slowly increased and fast transition on the output. So input is slowly increasing and fast transition on the output. So it's the first property. And second property, so in this schematic the voltage transfer characteristics, it has a two different threshold voltage switching activity. So these are the two important properties of schematic. So first property is input is slowly increasing and fast transition output. So it's the first property. And second property, in this voltage transfer characteristics, two different threshold voltages are available. So it's a voltage transfer characteristics. So in this characteristics we have a two directions flow of voltage. So x-axis represent V in, y-axis represent V out. So first the voltage is transferred from minimum voltage to maximum voltage. So this point namely called as VOL, this point called as VOH. So high output voltage, low output voltage. So it's a one direction. And next direction, the output voltage, the voltage transfer from maximum voltage to minimum voltage. From maximum to minimum. So it's a other direction. So in this voltage transfer characteristics, it has a two threshold switching activity. So threshold switching voltage. So it's called as Vm plus, this one called as Vm minus. So in this voltage transfer characteristics, it has a two different threshold switching voltage, Vm plus and Vm minus. So VOH is the output voltage high and output voltage low. So here the voltage is transferred from minimum volt to maximum voltage and maximum voltage to minimum voltage. So this particular region, so this is called as hysteresis. So how the noise input signal is converted into digital signal. So first I take the noisy input signal. X-axis represent time, y-axis represent input voltage. So it's a noisy signal. So in this input waveform, it consists of two threshold voltage. So Vm minus and Vm plus. So already I told In this symmetrical, it has a two important property, and second property is this voltage transfer characteristics. It has a two different threshold voltages. So in this noise waveform also, it has a two different threshold voltage, Vm minus and Vm plus. So this noise signal is applied to symmetrical. It's a symbol of symmetrical. So the output of symmetrical is square wave. It's T naught plus Tp. So Tp represents propagation delay. So in this input noisy signal, when this input signal is reached Vm plus. So when this input signal is reached Vm plus, so above that, this value considered as logic 1. So after the time period T naught, it reached the maximum threshold voltage, then this value considered as a logic 1. So you just look at this digital this waveform T and V out. So after reaching this T naught time period, it gradually increasing the value from 0 to 1. So now this value is logic 1. So after reaching T naught time period, so here T naught plus Tp is the time duration for rising the voltage from 0 to 1. So T naught represent reaching value, so Vm plus time period, and Tp represent propagation delay. So when this value goes below this Vm minus, so it considers logic 0. So likewise, this symmetrical is converted the noisy signal into digital signal. So next we see about CMOS implementation. So this is the simple structure. So in this structure, it has two transistors, PMOS transistor and NMOS transistor. PMOS transistor connecting VDD and NMOS transistor connecting VSS. So the input voltage is connected to PMOS transistor and NMOS transistor. So Vin. So we will get the output between these two transistors. And one more inverter used in this circuit. So it's V out. Let's say X represent for the output of this first inverter, and this PMOS transistor input is connected to output. Okay. So this output is connected to input of this NMOS. So M1, M2, M3 and M4. So in this CMOS implementation, we find the threshold voltage. So threshold voltage is based on the transistor ratio. Transistor ratio. So transistor ratio equal to Kn by Kp. So NMOS transistor by PMOS transistor. So based on this ratio, we will find the threshold voltage level. If the ratio is increased, the transistor ratio is increased, so threshold voltage is decreased. If ratio decrease, threshold voltage increase. So this ratio is inversely proportional to the threshold voltage. So here the input value is 0. So initially the input value is 0. This output value 0. So this 0 is given to input of PMOS transistor and NMOS transistor. So in this case, this M1 transistor turn on, M2 transistor turn off. Then this output signal is feedback to M3 and M4. So output voltage is 0. So this 0 is applied to PMOS transistor and NMOS transistor. So here M3 turn on and M4 turn off. So in this inverting operation, these two PMOS transistors are turn on and one NMOS transistor M2 is turn off condition. So the transistor ratio M2 by M1 plus M3. So likewise we find the transistor ratio. If you are changing the input voltage, so based on the turn on transistor, so that include in this to find the transistor ratio. So then monostable. So what is monostable? So monostable is a circuit. This circuit is generating the pulse of a predefined width every time in this quotient circuit triggered by pulse. So it's called as a monostable. So in this monostable only one stable state. Now I will draw the one shot triggered circuit. So it's a delay block TD. Vin is the input signal. Output of a delay is connected to input of XOR gate, and another input is connected to Vin. So it's V out. So initially V in signal is 0. So initial case V in value is 0. So this 0 is transferred to here. So XOR gate one input is 0. Then this delay output is 0. So 0 0. You just apply the XOR property 0 0 in the sense output is 0. If I change the input value from 0 to 1. If I change the input value from 0 to 1, so now input of delay circuit is 1 and XOR gate another input is 1. But the output of the delay is 0. Still this value is 0 because I just here applying the delay. So after the delay time only this input value 1 is transferred to here. So this 0 is applied to input of this XOR gate. So 0 1, this value output is 1. So the output value is changed from 0 to 1. Now the delay time is over. So after completing the delay time, this 1 is transferred to here. The output of the delay circuit is 1. So this 1 is applied to input of this XOR gate. So 1 1 0. So during this delay time, the output is 1. So after the delay time, it may be changed to 0. In this monostable, it has a only one stable stage. So 0, then 1, then 0. Again, the input value changes. Then this output value goes from 0 to 1. So likewise, this pulse will continue. Then we move on the astable. So astable in the sense there is no stable state. So it's a simple circuit. So in this circuit, multiple number of inverters are connecting cascade. The final output of the inverter is fed back to input of first inverter. So it's V in, it's V out. So continuously changing the values. So for example, V in value is 0. So first inverter input is 0. The output of the first inverter is 1. Then second inverter input is 1, output is 0. Then third inverter input 0, output 1. Fourth inverter input 1, output 0. Fifth inverter input 0, output 1. Then this 1 is feedback to input. Now the input value is 1. So then 0, 1, 0, 1, 0. So likewise there is the input values and output values continuously change. So there is no stable state. So this astable is mainly used for generating the clock frequency to trigger the integrated circuits. Then voltage control oscillator, current stored inverter. So this inverter circuit is replaced to frame the voltage control oscillator current stored inverter. So this is the simple circuit. So in this circuit it has a 1 PMOS transistor and 2 NMOS transistors. So Vin is connected to PMOS transistor and NMOS transistor. So output get from here. So it's V out. This one is V control. So analog voltage control circuit. So analog voltage is given to input of this M3 transistor. This M1, this M2. So in this modified inverter, the discharge current is maximized. So discharge current is maximized. If you need to minimize the discharge current, add the excess transistor. So this M3 NMOS transistor is the excess transistor. This transistor is helped to reduce the discharge current. Reduce the discharge current. So reduce the V control signal. So reduce V control signal, minimize the discharge current. So in this case the propagation delay is increased. If you need to reduce the propagation delay, reduce the frequency and reduce the propagation delay. So in this as table, the first circuit represents ring oscillator circuit. So this circuit continuously changing the input and output values. Then next circuit is the voltage control oscillator current stored inverter. So in this inverter we can use the excess transistor. So V control signal is given to input of this M3. So based on the V control signal we minimize the discharge current. If the propagation delay is increased, if you need to reduce the propagation delay, reduce the frequency. I hope you understand the concept very well. If you are watching first time in my video, kindly subscribe and support us to make a lot of videos. Thank you.